Hi guys, I am doing a demo video on my version of the E11 Open Blaster project. If you're not familiar with the Open Blaster project, basically it is taking a commercially available blaster, toy blaster such as this, and then opening it up, gutting it out, and replacing the insides with your own electronic components to add better sound and better lights. So essentially you're going to make the blaster better than what it came from the manufacturer as. This is a Hasbro blaster, very popular for this type of build. It's a pretty decent body. It's somewhat accurate, not quite as accurate as the true Sterlings, but it's close enough that it works. And the nice thing about these is you can also get some resin add-on parts that you can glue on to make it look even more realistic. So if you can find one, they're not made anymore, but they were made. They were released at least 3 different times in the past, so you never know. You can still find them on eBay, and with any luck, sometime they might release another one, which would be nice. So anyways, the history on the project for me was that I actually started working on this back in 2012, and at that time I had the shot counter developed, which is the same LED bar graph that's been used on many blaster builds similar to this. And at that time, 4 years ago, there weren't really great sound options out there. I was trying to use a micro SD card reader, and it worked, but the sound was so crummy that it just wasn't worth pursuing to finish out the project. I even tried going with a full-size SD card reader, and that one I never could get to work either, so I just let the project die at that time because it felt like it was the wrong time to try to do it. But now that we fast forward 4 years, there are several different sound options out there, and I kind of got to a point in my trooping career where I have 5 different costumes for 2 clubs, and I don't have the room to make any more costumes. I don't really want to invest in it anymore. So I still wanted to make stuff because that's what I like to do. So it just felt right to jump back and work on the blaster project again. So that was my history with it. I went pretty basic with this. 2-button operation. I got the trigger and then selector switch. The selector switch is right where it should be. I actually had to grind down the existing selector switch that was molded into the blaster frame. So I'll start with the shot counter. Basically it's the same thing that you see in other builds. Every time you press the trigger, one of the LEDs will decrement to let you know that you're 1 shot less than where you were. And then of course the red tip at the end when you fire the blast. So what we know from the movie is that the E11s had 2 settings, blast and stun, and that's kind of where I wanted to stick with mine, because as you develop one of these, you're going to quickly realize that if you load a bunch of sounds on, you don't really have a quick way to jump from blast and stun, which are your 2 common settings. If you have a bunch of sounds on, you kind of have to cycle through your entire list to get back to the beginning, unless you build in some sort of quick reset button, which is, another button to have to mount down and worry about. So I just kept it simple with blast and stun. If I press my selector switch, you're going to see 2 lights flash on my shot counter. 2 lights flash means that I have advanced to sound 2. Sound 2 is my stun setting, which I've added the blue light for. And then also, when you get down to the last 3 shots, 3 lights on the bar graph start flashing to let you know you're running low on power. 2 shots, no change, same thing, same blink rate. But then when you get down to the last shot, that remaining LED starts blinking fast to let you know that you're really running low on power and you're down to the last setting, or the last shot. So after you fire the last one off and pull the trigger, nothing happens. These are power cell driven weapons, so essentially once the power's out, nothing should happen because there's nothing left to power the weapon. So I just wanted to keep it simple that nothing happens once you get down to the last shot. In order to reload, I built in that you have to wait at least 3 seconds, and then after 3 seconds have passed, you can press the selector switch and you will be reloaded back to full juice. So then, I did build in some configuration settings to improve what you can do with the blaster. So if I press both buttons at the same time, I will drop into my configuration mode. So right now you see 2 lights flashing. That's telling me that I am in the 2 sound mode. So if I press my selector switch, now 8 lights are flashing. That's 8 sound mode for me. So at this point, if I were to press both buttons again, I would exit out of configuration, but I'm going to advance actually to the next configuration mode to kind of show you what's next. So I'll press the trigger. That pops me into the next mode. So now you can see 5 lights flashing. And actually it's evens and odds. So you'll see 5 flash and then the opposite 5, 5, 5, 5, 5. Kind of that every other light flash. That's standby mode in the configuration. So if I were to press the trigger, I would advance past this mode into the next mode, but I'm actually going to press the selector switch to select this mode and go into standby. So standby is essentially my programming or my software solution to the on-off switch. Since the bar graph with the lights on there, it does chew up a lot of power, so it drains your battery faster if you have it on for extended periods of time. So instead of mounting like a separate on-off switch, I went with a software solution to avoid additional wiring and stuff to deal with. So basically in standby I can press the selector or press the trigger or the selector and nothing happens. I actually have to make a conscious effort to exit standby mode, and to do that it's the same thing. I will push both of the buttons at the same time and that will pop me back into the regular operation mode. So it pops me back right where I left off, which was on the stun sound with 1 shot was missing, so now 2 shots are missing, so I just fired it again. So we've already been in the configuration mode where I selected to go into the expanded 8 sound mode. So if I press the selector again, 3 lights will flash for the 3rd sound. 3rd sound is the Han Blaster sound. Again, we'll press the selector. This time 4 lights will flash to tell me I'm in sound 4. Sound 4 is the Django Blaster sound. I think probably when he's fighting Obi-Wan. Selector again. 5 light flash. This is the Droideka sound. And this one actually I kind of like. It sounds like a nice burst setting for E11, so it's just kind of, I like it. It's fun. Sound 6 is the Jawa Ion Blaster. This one's fun too. I added the blue light for this because it kind of sounded similar to a stun weapon. And then you see R2 kind of spazzing out with blue electricity around him when he gets hit with this. Nope, I'm out of shots. Reload. Sound 7 is the Boba Fett sound. I think this is from when he's shooting at Luke in Cloud City, because it almost sounds like a ricochet's going on. And then selector again. 8 lights flash. This is the final sound in my arsenal, and this is just that the stupid Geonosian gun, whatever they have, kind of weak sounding thing. Not very menacing sounding. So that was sound 8. Now if I press the selector again, that drops me back to sound 1. So as you can kind of see what I was talking about before, if you just have all those sounds loaded with no quick way to get back to your initial shot, you kind of have to cycle all the way through the different sounds to get back to sound 1, which I wanted to avoid because I wanted a quick way to switch between blast and stun. So from there I have just one more configuration. So I'm going to jump back into configuration mode. So my first configuration mode was the sound selection between the limited and the expanded sounds. So we advanced past that. Mode 2 was the standby mode. I'll advance past that because we've already been there. Mode 3, all lights flash. And this is my volume control mode. So my trigger is volume up and selector is volume down. It's set that when it's on, it's pretty much full blast. So from here I'll hold the selector to go down. And you'll be able to hear the sound slowly wind down. You can dial in to exactly where you want to be, and this is helpful if you were in some venue where you didn't want a very loud blaster going off. So you could hear it kind of wind down. I'm going to go back up. And then, same as before, both buttons will exit me out of my configuration. Oops. Okay. So both buttons pressed. Back into operation where I left off with, looks like 5 shots missing. Same sound that I was on. So then, yeah, that's it. Basic operation. My version of this project. Now, I did want to spend some time talking about what it would take for you to do this on your own. And basically, I'll start with saying, is this something that every person can do? And the answer is no. It's not something that is probably for everyone. You basically have to have working knowledge in 3 areas to complete this. The first being coding, which is programming, and then you have to do some electronics, as well as general modification work. And if you're one of my friends through costuming, then you probably have the modification part taken care of. That should be a piece of cake for you, but the other 2 areas you may not have dabbled in before. So, coding-wise, the Arduino language is very similar to C++ or C#. So if you're familiar with one of those, you'd be golden as far as how to program it. For me, I'm a programmer by profession, so the coding aspect of the build was the easiest part for me. I spent about 10 hours. That was my 2016 time. I'm not sure what I spent back in 2012 to develop the shot counter. I'm guessing it was probably between 3 and 4 hours at that time. So, coding aspect, it's not too challenging because basically you're just dealing with some flashing lights, and then you're using an Adafruit sound library to play the sound that you have stored on the board. I guess I kind of skipped over that part, but basically the guts of the project is using an Arduino Nano microprocessor and then a Adafruit sound module to control the sound functions. So after coding, electronics wise, nothing too major. You're going to have to know how to do some light soldering and basically run wires and then power your components. So if you've worked with Arduino before, then you probably know how to do these things, because with an Arduino project you have to use your code to power something. So even if it's just a flashing light, you're familiar with running a wire from the Arduino to the resistor to a bulb and then making it flash. But if you've never coded a day in your life, you've never done any programming, you're probably going to not want to start on a project like this. You'll probably want to start with several smaller Arduino projects to get your feet wet and get familiar with how you want to do this. Coding wise, back to coding, yeah, actually this sketch was all mine. I started from scratch with it, everything on it I wrote. Reason being, versus sketches that you can find online out there from other people that have done these builds, is I hate trying to modify other people's code. I'd rather have my own stuff that I know exactly what I have to tweak or change in order to make it do what I want to do. So it's also a little more rewarding for you if you can write your own code from scratch and just make the blaster completely yours. Let's see, last component, modification. This was a big one. This took a good chunk of time. I want to say at least 20 hours worth of time, just from opening up the blaster and then cutting out the different brackets that you don't need for what you need to do, that are just going to get in the way, because there's like a lot of little brackets on the inside of the Hasbro body that were used to hold different things, and you don't necessarily need any of those anymore. So essentially I kind of almost hollowed out everything that was in the blaster and made room for my stuff. And then you kind of have to take time and think about where you want to put your components. So my suggestion for that is to start with your largest items and then work down to smaller items. For me, my two largest components were a speaker and then a voltage regulator. And the speaker I put up here, and voltage regulator was back here. The reason why the voltage regulator is needed is because the battery is actually like an 8-volt battery that I'm using, and the Arduino and Adafruit modules like to operate off 5.5 volts. So I found a digital voltage regulator that I was able actually to dial down from 8 right to 5.5 so that everything works nice and smoothly and that you're not bleeding extra voltage or amperage out into the other components, which can cause havoc on brightness of lights and all that stuff. So that's that. Let's see, then after the speaker I have an amplifier for the speaker, which I tucked in right in front of the speaker because it's really small. Behind the speaker I put the Adafruit sound module, so all the sound stuff is handled in the barrel. And then from there, the shot counter, there's really only one place that's going to go. I think I have the Arduino module either right behind the bar graph, or it's right in front of the voltage regulator. I'm not quite sure anymore. One of those two places. But yeah, that's basically it. So cost-wise, what are you looking at for cost? Let's see. So it is not a cheap project. I'll be straight up honest with you. I spent about $135 to do this. So your big hitters are the blaster body, which you can find on eBay for about $25 shipped to get a used one. And ironically, they're actually less than that when you bought them new in the store, back in the 90s even. And then the Adafruit sound module is like $28, so that's pretty pricey. And then for this blaster I put on a Doopy-Doo's conversion kit, and those ship from Europe, so that runs like $36. So right there, just those three components were really close to the $100 range. And then from there you just have a few extras like the battery and battery holders. The amplifiers are pretty cheap. Those you can get for under $5. Speakers you can get for under $5. The voltage regulator I got was I got that from Amazon, and that was like $9 shipped, and you can find them cheaper on eBay if you want to order it from China and then wait 3 weeks to get it. So yeah, that's about it. Rewarding project if you want to plug away and try to make your own. It's fun. It will frustrate you, but if you keep plugging away, I'm pretty confident that you can do it. So, thanks for watching.